This is really, really exciting. An article has come out in Italian about an Italian scientist who has done a study regarding the age of the Great Pyramid, and the results are mind blowing. It could have been built 20,000 years ago, or maybe more. So, this is reinforcement to everything that I've been saying. And I just thought, well, it's in Italian, but it's been translated, and I would like to read the important bits to you. The article is dated the 28th of January 2026, so it's very, very new. And this is the source of the article so that you can look up the actual original paper written on the subject. The heading reads, Italian engineer measures the erosions of the Egyptian monument called the Pyramid of Giza. I think they mean the Great Pyramid of Giza. The stone clock indicates that it may have been built 20,000 years ago during the Neolithic and then restored by Cheops, aka Khufu. It then goes on in the article to say, at the base of the Great Pyramid of Giza, contiguous limestone surfaces show significantly different degrees of alteration attributable to different times of exposure to atmospheric agents. A study published in January 2026 by the Italian engineer Alberto Donini is based on this observation, which proposes an alternative dating method, the relative erosion method, REM, be applied to the monument attributed to Cheops. The analysis, based on quantitative comparison of erosion between surfaces exposed in different eras but belonging to the same lithological context, leads to a chronological estimate that deviates radically from the traditional dating. Clearly, these Italian scientists are looking from a totally different perspective and are not, discouraged by the archaeological narrative. The article goes on to say that in January 2026, Alberto Donini published an article proposing an unconventional dating approach applied to the Great Pyramid. The results, if taken literally, lead to a disruptive conclusion. The erosion patterns observable at the base of the monument would be compatible not with a construction date of around 2560 BC, as established by the Egyptologists, but rather with an enormously more remote era up to tens of thousands of years earlier, in the middle of the late Paleolithic, a hypothesis that, precisely because of its scope, requires to be described with precision and evaluated with caution, the article says. The heart of Donini's work is the belief that stone erosion can work like a natural clock if read in a comparative way. REM does not measure an absolute rate of degradation, but compares adjacent rocky surfaces made of the same material and subject, at least in theory, to the same environmental conditions. In Giza, this comparison would be made possible by a well-documented historical narrative surrounding the removal of the blocks of fine limestone that originally covered the pyramid, making it smooth and reflective. The article goes on to say that medieval sources and archaeological analysis agree that much of the coating was dismantled after major seismic events, particularly the earthquake of 1303 AD, and reused in the construction of Cairo. As a result, some limestone surfaces at the base of the pyramid have only been exposed to atmospheric agents for about 675 years, while others, immediately adjacent, would have remained exposed since the original construction of the monument. According to Donini, this time difference is an ideal natural laboratory. The method involves measuring the wear of the stone in the form of pitching, microcavity, and uniform loss of material, and quantitatively comparing these young surfaces with old surfaces. So this is where it gets exciting, because if erosion proceeds approximately linearly, the ratio of volume or depth of lost material would make it possible to estimate how long the most eroded surfaces remained exposed. The study is based on 12 measurement points distributed around the base of the pyramid. At each point, Donini documented and estimated the erosion of pavement slabs or limestone blocks, clearly distinguishing the side that remained covered until the Middle Ages from the one exposed from the beginning. In one of the most illustrative examples of the study, the same slab shows on one side a deeply stunned surface, and on the other an erosion barely hinted at. Applying a linear erosion model, the calculation returns that for single point, an exposure time of more than 5,700 years before the present, so already older than the official chronology. Other points, however, produce much higher values. Several of the measurements suggest equivalents of 20,000, 30,000, or even 40,000 years of exposure. So doing the math meant that it was a value of 24,900 years before present day, which equates to 2,900 BC. So Donini insists on the fact that REM does not aspire to fine chronological precision, but to identify a magnitude of time frame. So to make uncertainty explicit, the article goes on to say that by applying a simple statistical analysis, he calculates the standard deviation of the results and builds a Gaussian-type probability curve. Based on this model, the probability that the Great Pyramid was built between 9,000 and 36,000 BC would be equal to 68.2%, with a probability peak concentrated around the first millennia of 20,000 BC. It's a very broad range, which reflects both the dispersion of the data and the experimental nature of the method. Donini himself dedicates ample space to sources of uncertainty. The erosion of the limestone rock is not a constant process over time. In addition, the climate of Egypt in the late Pleistocene and the ancient Holocene was probably wetter than it is today, with more frequent rains that could have accelerated the degradation of the stone. Another concern is that modern pollution and acid rain and heavy tourist trampling may have increased erosion rates in recent centuries, distorting the comparison for the more recently exposed places. The article also addresses human activity that also introduces variables that are fairly difficult to model. For example, the thousands of visitors that pass through the Giza plateau every day, while during the pharaonic times there were very few. The article also discusses how the Sphinx being buried for long periods of time under the sand may have protected some surfaces from erosion for centuries, even millennia, interrupting the ability to assess the overall age of that stone to a precise extent. However, with the use of multiple measure points, and the average reduces the overall error. But the scientist recognizes that individual values can be over or underestimated, but the use of the multi-point technology enables the scientists to come up with conceptual periods of time that are more likely. The massive contrast with the archaeological timeline is very clear. Egyptology places the construction of the Great Pyramid during the reign of Khufu in the 4th dynasty. To the archaeologists, it is reaffirmed by certain evidence, i.e., historical documents, inscriptions, utensils, radiocarbon dating of the organic material around it, and the archaeological context they have regarding the Old Kingdom. But all this evidence actually points to a lot of activity taking place on the Giza Plateau during the Old Kingdom period. But the evidence is equally as consistent with the theory that the pyramid skeleton essentially was already in place, the Sphinx was already there, and that the Old Kingdom pharaohs decided to take this area on as a project. But if we look purely at the archaeological framework, the dates provided by the REM are difficult to integrate. To fill the discrepancy, the scientist looks at a hypothesis that has long been present in more marginal literature. The pyramid could be prior to Khufu. And if we look at it from this perspective, he would have limited himself to restoring, readapting, and safeguarding this treasured area, like placing the Torah limestone casing stones on the structure that is the Great Pyramid. To spell it out, what is being suggested here is that the pyramid could be prior to Khufu. But obviously, this theory is strongly rejected by archaeologists, and they say it is not supported by the archaeological evidence. So it's not a surprise that the mainstream have not been seemingly interested, in doing a peer review or even entertaining the idea that this study could be of value. The article acknowledges that there are other scientific fields that seem to be contradicting what archaeologists are saying about certain stone surfaces, certain monuments, and we should be listening more to the engineers and material sciences and the people who actually have the technological and scientific knowledge to do an assessment of certain places. The article concludes with the following statement. Only independent measures, cross-checks, and an open discussion with the scientific community will be able to establish whether REM is destined to become a complementary tool or remain an isolated exercise. If you want to check out this article for yourself, you'll find it on the website stilearte.it, and its source is listed out as well, the paper by Donini. So I suggest, it's worthwhile for you to read the whole thing and check it out for yourself, because this is more evidence and it reinforces what the other Italian scientists have been saying about the Giza Plateau.